So welcome to the 2023 question B2. It's an intersecting planes question. So the image on the right shows the Glasshouse Hotel in Sligo. The hotel consists of a series of planar glass surfaces. As you can see here, glass surface and glass surface. Figure B2 shows the plan and elevation of two intersecting planar surfaces A, B, C. So A to B to C to D, and B, C, E, F, B, C, E, F. Okay, we can see A, B, C, D here, and then in the plan view, B, C, E, F is appearing as an edge view. Okay, so it's a vertical plane there. The drawing, part A, they want us to draw the given plan and elevation of intersecting planes A, B, C, D, and B, C, E, F. Okay, so they just want us to draw this. They said plan here instead of before elevation, so that kind of always gives the hint that's what we should start with. So looking at our plan, we've got it's 25-degree angle, okay, and at 90 degrees to that we're going to have our planar surface AB or ACEF and the location of A and D, okay. We've got 75-degree angle, and we got some heights there, and you can see parallel lines. So all of that will come into play as we set this out. So say about here. So give me an edge, and I'm going to measure an angle of 25 degrees. Okay, so one side of this, we can see it's 55. Let's measure 55. And sliding sets for example, we have to do a 90-degree angle, 90-degree angle. Okay, so we'll now measure 50, so that's going to find the EF, comma F. We'll measure 50 then. To find C, and then a further 30, 80 total, to find B. That's our edge view of that surface, so for those. Alright, now I need to measure this 75-degree angle. See. That's located near point D. And at the minute now we can't find A. There is no measurement there for A, or no angle there for A. So we'll have to come back to that in a moment. Okay, so I'll move up to my elevation. Let's see if I project vertically straight up there. E and F are in that position. So E is base, F is there. Project it further to get that height of 35, because we'll use that in a while as well. At 35. Okay. Side. Okay, so we've got our E, we've got F. C is on the ground around the XY line, and so is D, so I can draw those from plan up. Up. C and D. Okay, we have the position of B as well, so let's draw B up. and B is at that height 35 above F. So I can draw a line CB. And BF. There's B. Now we can see that relationship between those two lines. They're parallel. So I can use sliding set squares. Draw a parallel line from D. And A, we're told, is a height of 60 up. So there's A. Drawing that back to there, and B, drawing that to there. Okay, so those two are parallel to each other. All right. So lastly, then we just want to bring A down. A, and I can complete that plane A, B, C, D. Okay, so I can give that a tick. I've set up my plan and elevation as shown. Next up, they want us to find the determined dihedral angle between the planes A, B, C, D and B, C, E, F. So what line is common between those, or what is our line of intersection? You can see there, BC, BC, that is the shared line. Okay, and we can see that's where they intersect. So what we want to do is we want to look out perpendicular to that line, see it as a true length, and then once we have it as a true length, we want to look along it and see it as a point view, and that will give us the projections of the dihedral angle. So CB, here's CB. I'm going to look down this direction to see it as a true length. So our XY line, our X and Y1. Okay, X1, Y1. And we'll project all instances. So project all my points through. Now I could take a lamina of each of these surfaces. Okay, we don't need all 4 points, but for the sake of having to do 2 extra points, it's completely fine. So project it down from my auxiliary elevation. Alright, so when I'm projecting plan, I'm always creating an elevation, so elevations have the same heights. And C, E, and D have 0 height. So here will be E, C will be here, and D will be here. So those are 3 points already found. F, here's my height for F. Pull F down. F, my height for A. A down. And my height for B. Okay, so let's draw our important line, which is CB. That's our true length line. Okay, we've got planes A, B, C, D. So A, B, C, D. I'm looking in from this side, so I'll see A, B, C, D as a heavy edge for all of us. And B, C, E, F, so that will actually all be heavy as well. So no hidden details when we look from this angle. We equally could have looked out along this way and drawn our auxiliary elevation there. That's completely fine as well, but we just went with this. So now I need to look along that line. Okay, so along my true length line. Could be tight enough on space here. So maybe we should draw out there, but make it work. So keep my XY line nice and close. So this is my X2, Y2. Project out all our points. Okay, and now we're doing auxiliary, second auxiliary, so we go back 2 views. Okay, we're projecting from an auxiliary elevation, creating another auxiliary plane, so we go back to our XY. Now I just want to double check I don't need a dot on here. My furthest distance A. Get away with that. Yeah, we should get away with it. Okay, so my distance here for B from the X1, Y1 back to plan, follow B out, B. C, same distance in E, same distance as C. Actually there as well, yeah, because that's my point view. Stop thinking there. So that's my point view of my true length line. Then E, that distance to there. And that F, same distance. Yeah. So now we have an edge view of the plane EF, BC. And next up we need to get the other plane. So we've got BC, I've got, we need to get D. So D, follow D out, and A. Okay, so they're actually they should be on top of each other as a parallel line. It's just knackered in what I did. So that should be one continuous line coming out here, and they should be 1 point. Okay. Okay, so that has found my dihedral angle between those, and we'll always find the measurement of it. Okay, that at 76 degrees. Okay, so my dihedral angle, I just about squeezed it on the page there. I found it. Now, we've got P is a point on the edge BC, which is located a true distance 55 from B. Draw the plan and elevation of DP. Okay, so they want us to draw or find a point on BC. So we've got BC in a couple of different views here. They want us to measure a true distance of 55. Okay, we know in this view we've got the true length. Yeah, the true length of BC. Okay, so we can measure a true distance of 55 from B. So 55 from B. So let's find this point P. All right. Now we just need to project that back to the other views. So we're kind of working in reverse of what we have done. So sliding set squares, sets my angle of projection, and we're projecting that back onto the line CB or BC, which is there, so that's point P, and we project it up onto the same line. That's P again. I'm actually going to use a color here now to highlight that line. Let's get that. So they want to show the line DP. So D to P over here. And here. Resting on that surface ABCD. Okay. So there we found that. Now determine and indicate the true length of DP. Okay. So we've got this line here, DP, in this view kind of sloping away from us, and in this view sloping down away from us. So we could take an auxiliary view. That would be one way of doing it, which would be similar to what we did here, finding a true length. Okay, so I could just look out that way, x1, y1, take my heights from the elevation. That's one way. Okay, but just to vary it up, let's rotate that, just to do something different. Yeah, so let's create essentially a cone. So P as my center of rotation. I'll rotate that around here and project it up. So, or even let's rotate it down. Rotate it to here. So I'm looking at it perpendicularly. Okay, so that's it. I've rotated it around to this position. Now we'll project it up to the elevation. Okay, so that's my true length there. True length of DP. Okay, so it's being rotated back. Okay, and that's straightforward enough. Nice quick one. But like I said, if you prefer doing auxiliary views, you can do an auxiliary. Then finally, determine the true angle between the edges AB and BF. So true angle between AB and BF. Okay, so if that was a plane, and that was a plane AB and BF. Okay, let's get a little color here. So essentially we're getting this kind of a plane. Here's the equivalent plane. And they're asking us to find that true angle. Okay, so in order to do that, we need to see the true shape of that plane. Okay, there are a number of ways of doing that. So we could take an auxiliary, do two auxiliaries to get get a edge view or get a view of it. But what I'm going to do is I'm going to take a horizontal line here, okay, and find that down here, and that line will be a true length line. Yeah, that line will be a true length line. So if I look along that line, then I'll be able to get an edge view of this surface, just this surface. So we're shortening that surface just there. And then I could rotate it, or I could do a second auxiliary. It's up to you. So let's do that first of all. Create that plane. So yes. Create that plane. Like that. Okay, so that's a true length line. Okay, so I'm going to look along that true length, And we know that if we see any line that's on a plane, if we see it as a true, or we see it as a true length, we can look along and see the point, and if we see it as a point, we'll see the whole thing as an edge view. So project out here. So here's my x1, y1. Okay, take all those distances then from my elevation. So A and this point here will be at the same height. That's my point view of that line. So put it in as a point. Alright, so you can call that point O. That point O here. Point O. So here is A, comma O. Alright. And now we need to find B. So the height of B. Set off my height for B. Yes, there's B. That's my edge view of that plane. Alright. So let's put this in the page. I could rotate this now and bring it back down. So it's a rebatment or a rotation. That's going to kind of cover up a lot of my drawing, okay? And I could also do an auxiliary view. Just want to make sure that fits on the page.